Hello everyone, I'm sure you are doing extremely awesome. This video we will be covering a conceptually very important problem, maximum path sum problem. So this is sort of an extension to the previous video that we had or the previous problem that we solved, that is finding the height. And over here we will just take that concept and extrapolate it to a much harder problem, and we will see that how this particular pattern is kind of related. So let's first try to define what exactly a maximum path sum is. So path, when we are defining a path over here, is like where no node appears more than once. And in other words, we can say that there is a continuous flow of node, and over there we have to find out that if we are taking a continuous flow of node, what is the maximum sum that we are getting alongside any of the path. So for example, if we just take this particular example per se, okay, so here you can see that this is a path, this is a path, also this is a path. But if we just keep on understanding around each node, like around this node and also around this node, things will come something like this, that for the node 1, what would be the sum? The sum would be the sum would be 1. For 2, again the sum would be 2. Why? Because 1 is only in this case is passing through 1, 2 is only, as per our consideration, is passing through 2. But if we are taking this complete set, for example, from here to here, if we take this part, then what is the sum it is becoming? This particular sum is becoming as 3, right? So if we are taking from 1 to 2, in this case the sum will be 3. Also, if I take something like 1 and from there the 3, like this particular path that we are talking about, then it will be the sum is becoming 4. Now suppose I am taking this complete path, like I am taking from here to here. If I am taking this complete path, in that case what happens? In that case, suppose if I am starting from 2, then I am going to 1, and from there I am going to 3. So over here this would become the sum as 4. Sorry, the sum will become as a 6. So over here, what exactly is a maximum path sum? If I try to define here, the max path sum over here is 6. So now let's try to take a little bit more trickier example with negative values. But I hope you understood this thing. If you just do a dry run by yourself, that will be further more clear to you. So now we are taking a little bit more trickier example where the tree will have negative values. So here, if I'm starting from 9, what I would get? So from 9, I'm getting that this particular guy, for 9, the path sum is definitely 9. Okay. So now if I take another part, like if I take this area of, sorry, if I take this area of 20, 15 and 7, what do we get? So with 20, 15 and 7, we are getting the path sum as 42. And also if I take this whole thing, like So here, if we can see like this value is also negative, and this -2 -1, everything is negative. Like this is negative, this is negative, this is negative. So if we keep on doing sum, like if we do a sum with 2 along with 3, what will become is like -5, right? And also if I do a 3 -1, it will be -4. So if we keep on taking them, it will just go worse and worse. So we can just say that what would be the value is the minimal minimum node that is there, or rather I should put it like this, like the maximum singular node will be my answer. So in this case it is -1. Okay, so now if we see this pattern very carefully, like whatever the things that we have been doing by traversing through all this 1 2 3 and then through this list, what we will be able to understand one core part is there could be 4 basic things we can do while standing at the node. Like for this case, what we did was we took a current node. So 4 basic stuff we can do while standing in any node. Okay, what we can do is, the first thing is take only the current value of the node. Okay, so over here as you can see, like if we just take this current value of the node, that will be my maximum in some way. Or what we can do is we can do the current node plus whatever coming from left, or current node plus whatever coming from right, like from the legs, like the max path, and here the max path. Okay, so this is the thing we can do. And also we can see that in case like our examples, why only left or right? Because as you can see over here, in a single go I will never be able to cover 9 10 20 and then this, right? So that will not be continuous. To cover 7 from 15, we have to go like this. So what we can do is either we can cover this 9 10 20 and 15, or we can cover this 9 10 20 and 7. That is why from any given node, either we can take its left or we can take its right maximum path sum. Okay, from algorithmic structure thinking perspective. So here I'd request you to do a dry run on this too and try to find out what would be the maximum path sum here. I'm not going to solve this for you. I'd request you to do this dry run. I will just give you the exact number that you should be getting. If you are not getting, then please revisit the earlier part of the video and try to understand what will be the actual maximum path sum. Okay, so here, in case you got 17 here, and in case you got like 8 here, then you have got the right answers. So just to reiterate over here, for this one, the whole traversal will get me 17, but not for this one. For this one, if I do a whole traversal, what I'll be getting? I'll be getting something like 7 over here, because 4 plus -5 will be 1, and then if I go to 8, it will the whole thing, the sum will come as 7. Whereas if I only take 8, the sum will be more than that. So in this case, probably we understand one important thing, that we can even skip our root, but the idea is somehow we need to get the maximum path sum. So now a probing question for you. As a node Your primary responsibility will always be to convince your parent node to include whether to include you in the max path sum calculation or not. So suppose if I take any tree like this. So here, while standing, suppose in the 5 or in the 3, you need to convince the minus 10 whether to take you or not. So whom do you think the minus 10, if it takes, it will be more profitable in terms of getting the max path? So definitely 5, because 5 is greater than 3 over here. So if I'm taking this path, I'm getting minus 5. Whereas if I take this path, I will get minus 7, right? If I take this path. Now, let's not go into let's not go into the exact formula right now. We are going to break down our problem a little bit more. Now let's extend this problem, and over here we have introduced another root node on top of the previous tree. So now we have a 7 as our root node, and as we can see now 7 have this part as its left node. So 10 got to decide whoever the path that is best for it, and it found that this path is best. So it is going to return what? It is going to return minus 5 over here, but 7 over here is getting 1, right? So whom 7 is going to select? 7 is obviously going to select this one. So at this point of time, the maximum path sum has been this, that is 5. But now with this, the maximum path sum will become 8. With this case, it is becoming 8. So now probably you understand that if we are going from bottom up approach, the similar thing that we did for the height calculation of graph, in a same thing, if we keep on delegating to the parent node the fact that whether to include you in the maximum path calculation, and at the same time, if you can keep the track of the path sum. For example, had 7 and 1 been not there, then with with not so surprisingly 5 would have been our answer. Okay, not 10 plus 5, because this will become minus 5. However, only 5 will become or will give us way more greater sum than these combinations, right? So here we have to keep on tracking the maximum path sum on each of the cases. Like, what is the maximum path sum when I am standing in the 5? What is the maximum path sum when I am standing in the 3? What is the maximum path sum when I am standing in 10? And then gradually in 7, 1, etc. And after, at the end of the full traversal, whatever the maximum number that we will get, that will be our answer. So let's take into the same example with a more fresh perspective, and two of the main thing that we decided, like the thing that we need to get is the max upward gain, or the max upward value that we want to pass, and the best path so far for a given node. So these are the two things we have to keep in our track. So if we are just doing a bottom up approach, like we did for our height based calculation, so we will be at first standing at the 5. So what would happen from the 5? So at the 5, the maximum upward gain that we are having at this level is definitely 5 itself. Okay, and what is the best path it can offer? The best path is the 5 itself there, nothing else. So now when it goes to the 3, what happens? It is same. The maximum upward gain it can offer is 3. Now the decision is with 10, which particular value it wants to what is the best path it wants to take, and what is the maximum upward gain it can made. So what is the best path? Best path is definitely this one, because it is getting the value as 5. So now in the upward, what it will be able to pass, it will be able to pass minus 5, right? Minus 10 plus 5. Over here, although we are passing minus 5, but you see 7 is getting a better path from here. It is getting 1. So what value does 7 will take? 7 will definitely take this one and then decide whatever the value it can pass to its parent, although it doesn't have any parent, but it will keep on calculating. So it will say that the max upward gain I can transfer is the value 8. So in that way, what will be the max upward path or the maximum path sum of this? It will be 8. So when I'm standing at 10, what will be the max gain I can pass in the upward? It is, it has to be definitely one singular path, like either the left or the right. So it will be something like, our formula will be something like that. This node dot value plus the max of, either it can be like, in case there is a negative value, it can be mm, the the best we can pass is 0, or it would be the whatever the thing that we can get from the left gain or the right gain. Okay, this is going to be the max gain. Now what is going to be the best path? Best path in this, the best path is going to be node.val plus either the left, like left as well as the right. So for example, if I'm standing on the 10, it can be the whole value will be 5, 3 and 10, because that will give me minus 2 instead of only taking 5. But if I have to pass it on to the parent, it has to be minus 5, because I cannot traverse in this way, right? I cannot traverse in this way. I have to take only this value to the top, or only this path to the top. So I hope you got the idea, and this is the crux of the problem, that while standing in a single node, the best path, it would be the node value plus the max of plus the max of 0 comma right gain. So when I say left or the right, it is basically the gain that I am talking about. Okay, so again, if I have to do a dry run with one more example, I will probably take a little bit more complex one. So in this example at the node 15, okay, what would be the actual gain? The left gain and the right gain both will be 0. So it will be just a local best, and the local best is coming as 15, and that we are going to pass um, onto the top as well. So over here from this, I'm going to pass, I'm going to pass 15 as only. Okay, right from here. Now the same is for 7. For 7 also, I'm going to pass with the same logic at the upward pass. Sorry, here it will be node 7, and here the upward pass will be also 7, right? And at the node 20, over here, as you can see, we are going to pass 7. And so node 20 has two options. Either it can take this or it can take this, right? This path or the 15. So definitely it will take this particular path, but The important point is if the tree ends in the node 20, what will be the maximum value? The maximum value will be actually this, because all of them are positive node, and it will be 20 plus 15 plus 7. That is, it is becoming 42 there. But while passing on to the top, so here the max value it is holding 42, but what it is going to pass on to the top? It is going to pass on to the top only this path. That means 35, right? Because there is a hope that probably this path will be a max one, right? Similarly for 9, we are going to pass over here only 9. So right now 10 has 35 as well as 9. So definitely it is going to choose 35, and what will happen is over here it will become 25, but that in reality we already have a greater value, that is 42. So 42 will be our maximum path sum. So at each level we are going to calculate two things, as we have mentioned over here, that what exactly is the best path. It is going to uh, it is going to have at while standing over here, like best path while standing over here is this, and plus alongside that at each recursion level we have to calculate that what is the value it can pass on to its top, what is the best value it can pass on to its top. These two values are definitely different, right? So now I hope you understand the fundamental of the problem. Let's move into the coding part of it. So in our previous problem only we have seen that there is a particular tree that I already have created, that is this public class binary tree, and this is a class and it also has a node, and using this class and node in Python we are going to solve this problem. So here let's get started. What we are going to do is we are going to define max path sum for us, and for this one we are going to take a variable max path sum and we are going to mark it as a float minus infinity. Okay, why minus infinity? Because we need to we whenever we are going to get a greater value than minus into infinity, we are going to mark it as a max path sum, and in the end we are going to return that as well. So we are going to write a recursion for this. How the recursion would look like is, before that I will just name it as recursion max path sum, and I'm going to pass whatever the node that I'm having, and here I need to mark it as a non-local. So non-local max sum of path, and if the node is none, I'm going to return a 0 as my recursion path. Sorry, I think I messed up with the naming. Anyway, so then I'm going to do a calculation of the left max path sum. Here I will definitely call the recursion, and in the recursion I'm going to pass the node dot left, and also I'm going to do the right max path sum. For that one also I have to do a recursion, and this will be node dot right, and what will be the sum of path. So the actual sum of the path that we are going to have is like the actual path, that will be basically the node value plus the maximum of the left or 0. So here only one path we can take, either the left or the right. So we are writing the code like this, that either we take the left or the right, and what will be my max sum of path, this value, my max sum of path would be the max of sum of path that I'm getting comparing with the previous max path of sum, right? So this is going to be my, this is how I'm going to make change into my max path of sum for each level, like as we have been discussing into our workbook. At each level we are going to calculate what is going to be my max path sum, and on each level we are going to report it back to this particular variable. And what are we going to pass on to our top, onto our upward parent? We are going to return the node value plus the max of left path sum 0 or right path sum. So here what we are returning at the top, in the top we are returning either the left or the right, whichever is the max one, or in case like both of them are negative, we are going to completely ignore it. And the sum of path, as we mentioned, sum of path is basically this full path, and while we are, like again, this this full path is the sum of path, right? And while we are returning anything, this particular path or this path or this path, these are becoming my for this variable, this is exactly what I'm going to return, either the left path or the right path sum as the highest one. And then what we are going to do is we are going to make a call to whatever the value that we have. So we are going to return max path sum from here. Now to test this out, I already have written some of the test cases. For example, here I have written a test case that which will be testing whether it is a whether in case the text max path sum is negative or not. Like here you can see -10 is the highest value among all the negative nodes, so the value is coming as, value should be coming as -10. So I'll be putting a debug point over there, and I'm just going to debug this test. As I start debugging, it came here, like it is going into each of these tests, and now it came to our test, and over there it went to max path sum. So you can see debugging, it came here. I will just go through a little bit of step regarding this. So we started from here, and then the max path sum, like for this sum positive, it is returning 11 and it is passing as expected. Now suppose I want to run this one. So for this I need to go to testing, and this one I need to debug. So over here you will be able to see that again I came into the binary tree, and then it is tracing me through this negative value, and it will return the maximum sum path as 10. And I'm not tracing the complete recursion tree because while drawing it I kind of explain it to you how the recursion would look like. So it would be my request that what you do is in case you have cloned this solution, you go to the solution like this way, okay, and then you go to the testing mode. In the testing mode you start the debugging, and at each of the step you keep on seeing what exactly is happening. For example, once you go to over here, you will see how the node is behaving. So at first the this particular node of the left side, the 20 came into the picture, right? So this particular node is being processed. As you can see, the value is 20, and then the write will be getting processed. What exactly is the write that is coming for this one? So the right and the left for this 20 is definitely 0. So the sum of path over here is 20. And what will be the max sum of path? Max sum of path is also 20, right? Because it doesn't have any children. It is completely with left and right side, it is having null as children. So the max sum of path is coming as that, and it is going to, at the top, it is going to pass 20 as well. So here you see 20 is being passed as a left. Now for right, what I'm going to do is, for the right also, I have a sum of path, and this sum of the path is now becoming 30, right? So now again, when it came to the right, the sum of path is becoming 10, and 10 will definitely be my max sum of the path. So over here in your variables, you will be able to see all those things in a complete detail. So it's my, again, kind of a suggestion that you go through all of these things by yourself so that you understand it by heart. Okay, so that's the video, guys. This is where we have solved the maximum problems, and we also have given the actual code for this. So we will see you in our next video. Till then, stay awesome. Bye.